how different, we have to go back in Earth's history to a period when a new form of organic matter emerged, one that challenged fungi's powers of decay. The fate of life on Earth hung in the balance. Rewind 300 million years to the Carboniferous period, a time when plants struggling to compete for sunlight had evolved into trees. That new organic material was wood, and it gave plants the strength to grow taller. But this evolutionary leap left fungi behind. They weren't able to decompose wood. The delicate mechanism of decay had been upset. Without decay, the trees grew, died, and lay where they fell. The effect on the planet's climate was spectacular. Professor Lynn Boddy is an expert in the history of fungi.
Trees absorb carbon dioxide from the air, they absorb nutrients from the soil, and then the carbon is locked up within the trees. So when they fall and die, the carbon is still locked up inside them.
So huge changes simply because trees can't decay.
Absolutely.
With fungi unable to break down wood, over time, more and more carbon was removed from the air and locked up in dead trees. The Earth's atmosphere began to change. Oxygen levels shot up from 20 to 30% as carbon dioxide levels dropped. This allowed insects to grow to gigantic proportions. Spiders were as wide as a human head. Dragonflies were 10 times larger than they are today. If the atmosphere had stayed like this, life on our planet would have looked very different. The stumbling block for fungi was a molecule in trees called lignin. It's what makes wood tough. It took 50 million years for fungi to evolve a way to overcome it. And Lynn is able to show me the modern descendants of the fungi that solved the problem.
Pick up that log there,
Yeah.
we could have a better look. No, the
That
one
one?
underneath, that
That
one,
one?
yeah.
Now, the first thing I see about it, it's not heavy at all.
Light as a
it hardly
feather.
weighs anything.
Yes, it's been rotted, and again you can see this is really white.
Why is it white?
It's white because the fungi have broken down the lignin that was in the wood,
Which would be brown normally.
which is brown colour.
It's pretty easy to see what effect the fungi have had on the wood, but can we actually see the fungi themselves?
We can't actually see them rot in the wood, not with our naked eye, because they're microscopic. Actually,
To show me the fungi in action, Lynn has grown this sample in soil.
what we've got
That's
here
pretty.
is a little piece of beech wood that's got the fungus growing in it, and then we put the wood on top of this soil, and the fungus has grown out of the wood, looking for other pieces of wood that they can colonise and get food from.
The fungus sends out a network of tiny threads called hyphae.
They've aggregated together so that we can actually see them with the naked eye.
And they're heading off to find other bits to eat.
That's exactly right.
The hyphae release powerful enzymes into the wood. They are able to break down the lignin into nutrients the fungi can then absorb. This releases carbon from the wood back into the air. It was the evolution of these enzymes that allowed fungi to rebalance the Earth's atmosphere.
If those fungi weren't here today, then decay would come to a grinding halt, and we'd be in a similar position to what we were in the Carboniferous period.
By evolving the ability to unlock the carbon in dead wood, fungi saved the world. We still rely on this delicate balance between all living things and the agents that can decompose them. At the Afterlife House, Another 8 days have gone by. Just after my last visit, we captured something extraordinary. The new rat that I left out in the garden has been buried by the sexton beetles, as I hoped it would be. Despite their size, it took the two of them less than 12 hours to get the whole carcass underground and away from rival decomposers. The female will lay her eggs in the rat so her young will have food to eat when they hatch. In about a month's time, we'll dig up the rat and see what the beetle larvae have done. Elsewhere in the box, bacteria and mold are still battling it out on the meat. The bacteria inside this sealed pack of burgers are hard at work, producing this build-up of gas. I'm not looking forward to smelling that. Where meat was left exposed to the air like these sausages, mold has been able to move in, suggesting that the bacteria have been overwhelmed. But just over 2 weeks into our project, and an army of even more voracious decomposers is taking control. The maggot population has exploded. Our pig is literally seething with them. Maggots are some of decay's most effective operators. The question is, how long will it take them to munch their way through the contents of our house? Well, I haven't even got into the box and already I can see escaping maggots. So even though we tried really carefully to keep all the insects on the inside, some have escaped. They can squeeze through the tiniest gap. The time-lapse cameras have shown a real fever pitch, especially with the fish and the chicken. I just want to show you the fish though. This has been completely eaten out. If I just look at that, look at the inside of that. It is just a writhing mass of maggot, and the smell of ammonia is just overpowering. They've eaten everything. They've eaten all the flesh. All that remains is the dry skin on the outside and the bones. These are the most efficient recyclers on the planet. I think they're just amazing insects. It's 15 days since I released about 100 blowflies into the box. As soon as they mate, female flies look for a place to lay eggs, up to 300 at a time. The gases given off in the very early stages of decomposition will have attracted them to the dead meat and fish. They're the ideal food source for the maggots when they start to emerge around 24 hours later. Now they've hatched, these maggots only have one aim: to eat non-stop. Now I've got the thermal image camera here, and this is actually quite a useful item because it can show heat that's produced by organisms. Now the fly larvae, when they feed en masse, they do generate quite a bit of heat. Now I'm just shining it on the chicken drumsticks, which are cold. They're not hot at all. The chicken's not very hot. But oh, look at that. The hamburgers are absolutely glowing like a beacon. Now that means that there are lots of fly larvae in there, and they're generating masses of heat, which actually makes them grow faster. Our time-lapse camera shows how maggots feed as a pack, so they can share not just heat, but digestive enzymes as well. They carefully coordinate their movements. As the meat in one burger runs out, the maggots move together, almost as a single unit, over to the fresh supplies of the second burger. Maggots are a perfectly adapted mechanism for turning dead meat into flies. At the head end, you've got these amazing hooks, which are basically just a pair of really sharp curved hooks with which the fly maggot rasps its way or rips its way through food. As you move further down, you see that it hasn't got any legs. There isn't any obvious head, thorax and abdomen, but what it has got are these bands of raised little bumps. They're like spikes for a grub, if you like. They're essentially bands of raised welts which help the maggot move through its food. So it's essentially in a pile of slop. By having these raised bands of welts around them, they're able to undulate through the food because otherwise it's very hard to move. At the other end, and let's go down to the back end, let's move back down. Now these two little structures here are actually the breathing holes of the fly. These are the spiracles through which it gets its air, its oxygen. And they're on the rear end, so it has a pair of them. They're quite big. And so it's able to insert its head right into wet food and still feed while its rear end is in the air. All in all, it is just about the perfect eating machine. To me, maggots are the clearest example we've seen so far of the fundamental principle behind decay. Recycling the nutrients from dead animals and turning it into new life. But of course, for many of us, they represent everything that's disgusting about decay. I'm intrigued as to what these strong feelings of revulsion are, and so I've devised a little test, and I'm going to put a £5 note inside a plastic bag. I'm going to hide it inside a tub, inside which I will put loads of maggots. So we're going to end up with a pretty simple test, which is essentially this. A large box full of maggots writhing around and a £5 note. Now I reckon only one person in 10 will be able to overcome their deep-seated revulsion from maggots and put their hand in to retrieve the fibre. Well, we'll find out. Right, who'd be happy to put their hand in a bucket of maggots, a tub of maggots for a fibre? Well, you would you?
It looks like my bin at home now. I can't do it, I can't do it.
£5 note?
I can't do it.
Maggots.
Oh.
It's a little gross that they're now writhing on my fingers.
Oh no.
Yeah, no.
No, no. No.
No, I can't do it.
£5 note. You're nearly there, you're nearly there. You've so nearly got it. Yes! This feeling of disgust is an emotion that evolved over thousands of years. It's not just maggots. All signs of decay revolt us. It's a great mechanism for stopping us from eating food that might make us sick. But it's also why we so rarely look at decay. We're hardwired to be repulsed by it. In the next few weeks, I hope our Afterlife house will start to show why this disgusting process is so important. Why decomposition is vital to life. And there's one part of our box where we're attempting to demonstrate that in a unique way. These dead mustard plants are the starting point of an experiment that will help me trace how new life emerges from old. I've made liquid compost from the mustard and fed it to these seedlings. We plan to track individual nitrogen atoms from the dead mustard leaves to see if they're reused in the new plants. No one has ever followed the cycle of life in this way before. And in a couple of weeks' time, we can come back, and with any luck, we'll be able to track this vital part of the cycle from death and decay to new life. It's the 23rd day in the afterlife house. The first waves of decay have now passed. Vegetables and soft fruit have been consumed by mold. In some places, there's not much left for them to feed on. They'll need to find new supplies. Anything with a hard skin, like this orange, remains apparently unaffected. Maggot activity too has begun to die down, leaving behind a sort of meat slurry in our burger packet, where these late developers eke out a meal from the remains. The majority of the maggots have started to pupate, the next stage before they turn into adults. So we should soon see an explosion in our fly numbers. And our chicken has gone through an alarming metamorphosis. Bacteria continue to rot away at it, releasing gases as they feed. This week, the carcass bloated to even more grotesque proportions before deflating as the gases escaped. 1 month into the project, and our house really isn't somewhere you'd want to visit, unless you had to. Every time I enter the box, there's one thing that hits me, and that is the all-pervading, hideous stink of decay. Imagine sticking your nose deep into a rubbish bin. That's the smell I'm talking about. But if you can get beyond your revulsion, the smell of decay gives real clues to its underlying mechanisms and the different ways plants and animals are broken down. So I want to share some of these smells with our audience, and so I've got 2 tubs. One's got vegetables in it, which are a bit far gone, and one's got a piece of meat, also far gone, and I want to see which of these 2 our visitors find the most disgusting. This is decaying vegetables, right? So I'm going to have a smell of that. See what you think.
It smells like vegetables still.
Yeah, have a good old sniff. It's not that bad, is it?
That's not terrible.
That's not terrible.
Smells like
Okay, I'm warning you. I think it's only fair to warn you. This is not nice. Have a good old smell of that.
That smells like a pig barn.
As expected, the meat gets the same response every time. That's pretty grim, isn't it?
His eyes are watering.
Your eyes watering. Rotting meat is far more dangerous to us than rotting vegetables, so we're programmed to find it more offensive. But what are we actually smelling? Plant cells are largely made up of starches and sugars, so when fruit and veg decay, they ferment, turning the sugars into alcohol and releasing volatile compounds which have a sweet odor. But fish and meat are going to produce really smelly gases like hydrogen sulfide, sulfur dioxide, and ammonia. So I'm just going to extract some of the gases from the inside of this decaying chicken, suck it up into this syringe, and then I'm going to just blow it over a gas analyzer. And look what happens. Look at that. The hydrogen sulfide has shot up to 10%. That really is smelling. Oh, God. Unlike plant cells, animal cells are made up largely of proteins. The foul-smelling gases are produced when these proteins are broken down into amino acids. To understand more about that process and why the smell it generates is such an important part of decay, I'm going to experience rotting flesh on a scale that even the box can't provide. At a secret location in northwest England, a grotesque but important experiment is taking place. 65 pig carcasses are being left to rot. They're part of an investigation into exactly how flesh decomposes under different conditions. And the smell of death is everywhere. Well, I haven't been here very long, and there's a real whiff of dead animal. Sometimes the wind changes direction, and it just catches your nose. I'm used to dealing with smells and excrement and stuff, but I'm just wondering if I'm really up to this, because there's a lot of dead animals around here. The pigs are stand-ins for human remains. The aim of the experiment is to help police forensic teams establish an accurate time of death based on the state of decomposition. Dr. Tal Simmons is the research director for the project, and she's going to help me understand how the different stages of decay account for what we smell. Good morning, Tal.
Good morning, George. How are you?
No, I won't shake hands.
Possibly not.
What have you got here?
Well, I'll tell you what, let's move the cage and then we'll be
All
able
right.
to see it a bit better. Well, we've got a pig that we put out 4 days ago. He's just begun to really show some of the early stages of decomposition.
The first thing that's obvious to me is that it's swollen up there.
Yeah, he's beginning to bloat. He may get a lot more bloated in the next couple of days. And that's due to the cellular breakdown inside the body. So all those cells are starting to collapse, the cell membrane is going, it's exuding all the fluids inside the cell, and a lot of those contain kind of digestive enzymes. So he's starting to eat himself from the inside.
The moment blood stops flowing in an animal, this process of cell death begins. As each cell membrane splits, enzymes inside are released and begin to break down the other cells. Bacteria then start to feed on these protein-rich contents, releasing the gases that are bloating the pig.
All of these gases that are being produced inside are coming up the digestive tract.
And so that smell is actually coming out,
That's right.
and that's what attracts the flies.
Exactly. We can't smell it, but the flies can
I
right
can't
now.
really smell. It's not
No.
obvious at all.
No.
But as I know from the rotting meat and fish in the box, it doesn't take long for the smell to become something we can detect. Oh, that's a lot worse.
Pull this off
Oh,
and we can
dear.
see a bit. Yeah, he's much
God.
more advanced, as you can see.
We're now smelling a cocktail of highly volatile gases and liquids produced not just by the breakdown of the animal proteins, but by the agents of decay themselves.
The body is composed largely of water. So as the cells break down and the cell walls go, you get the liquid coming from that, you get the liquid that was part of the organs, and you get the liquid that the maggots are also excreting as part of their digestive process too.
If you look at it really closely, it's actually rather interesting.
No, it's a
I mean,
fascinating
it's
process.
attractive, but it's,
I wouldn't go that far out.
Many of the molecules in this cocktail of decomposition fluids have a particular property. They're highly electrically charged. It's a bit like when you rub a balloon on a woolen jumper. The molecules of the balloon pick up a charge, which means they stick to other materials they come in contact with. Which is why the smell of decay can literally stick to our clothes. And it also explains why decay can leave a trace that lingers far longer than you might think.
Top off.
Tal's colleague Peter Cross is measuring what effect the decomposing pigs are having on the surrounding earth.
You can just draw the water up. It's even frothy,
Oh, it's foaming.
foaming, yeah.
Well, it's clearly not fresh. Ah!
That's pretty bad.
This is soil water taken from the site of a buried pig carcass.
This machine is passing an electrical current through the soil water and then measuring how well the soil water conducts that electricity.
The contaminated water is 30 times more conductive than soil water taken from 10 meters away. This is the trace that decay leaves behind.
We think that because of all the electrolytes that are leaching into the soil water from the decomposing pig, that they are changing the electrical properties of the soil water.
How long will that remain?
I would expect conductivity to continue increasing for up to 2 years.
So that really is a fingerprint of death, isn't it?
Absolutely, yes.
And it's a fingerprint that allows scientists to detect signs of decay, not just over years, but over centuries.
Okay, Chris, we're going to grab the remote probes.
Dr. Jamie Pringle is a forensic geophysicist. Today, he's using the conductive qualities of decomposition fluids to identify unmarked graves in this churchyard. Some are estimated to be 200 years old. Jamie's kit sends an electrical current into the ground to measure conductivity. It can detect electrically charged molecules left behind by the bodies buried centuries ago.
Oh, that's interesting, lads. Looks like it's going down there. I've just downloaded the data from the machine, and the results show there's 1, 2, 3, 4, 5 areas of blue, which means it's high conductivity results, which suggests to me that's where the graves are going to be located and where the decompositional fluids have been retained in the soil.
This technology opens up new possibilities in forensic science.
Not only can it be used for unmarked graves, it can be used for other things as well, such as looking for buried murder victims.
For crime fighters, the powerful, lingering effect of decay turns out to be one of its most useful qualities. We're more than halfway through our investigation of what happens when decay is allowed to run its course in a typical home. We set out to see how quickly its contents would be broken down and transformed into new life. 1 month in, and we have our most striking result yet. The clue is in the rapidly increasing fly numbers. These flies are the first generation to be born and bred in the box. 2 weeks ago, they were the maggots that were so active in all the meat. Once a maggot has fed enough, it pupates, and within about 7 days, the adult blowfly emerges. It inflates a soft, spongy sac on top of its head to help push itself out. Then blood pumps into the wings, spreading them out, ready for takeoff. There isn't anything better than flies to illustrate the transformative power of decay. The fly larvae have eaten this pig, and I want to show you just how little is left behind. Get this torn back, cutting my finger. It's quite tough. The outer surface of the skin is now quite dry. Look at that. Oh, ammonia. The smell of ammonia here is just quite overpowering. And if I peel it back, look at that. What we've got here is basically dry skin. There's a few bits of fat left here. All the meat's gone. The fly larvae have eaten this pig out completely. All that's left are some ribs and fat, and all that meat that was once pig is now flying around this room. Who says pigs can't fly? Seven days later, and the number of blowflies is becoming a problem inside the house.